Howdy, everyone. Um, just letting y'all know, still tuning a little bit of audio, but I think I'm ready to start introducing what's going on here. So this is Rookie to Rookie. It's we're presenting about some general tips and tricks and mistakes that we've made in the past that we'd like to show how not to make, so y'all can move from being a rookie team to overall increasing your competitiveness. This is being presented by my team, Team 19991 Chuckleheads, and Team 24457 Typhoon Stormbots. So, yeah, welcome to the stream, y'all. Hoping this goes well. So, just gonna explain here a bit. Yep, we are good to move to the next slide.
Right. So today's presentation structure, we're going to be talking a little bit about the middle step. Next up, we're going to talk about designing robots and what softwares we use for mechanics, the different types of drivetrains, intakes, things that help you design a good robot, a few programming tips, a bit about outreach and portfolio, and the best places for asking help. Right. So a little bit of an introduction about our teams. So we are Typhoon Stormbots, Team 24457 from Ajax, Ontario, Canada. We are well known for using DIY parts. We've been in FTC for 3 years now, and we really like using MS Paint.
Howdy, we are Team 19991, the Chuckleheads. We're a high school team from Flower Mound, Texas, and as our name suggests, we are always up for a good time, but we hope to remain competitive, and yeah, pretty much it.
Okay, so bit on to the middle step, kind of what we want to try and show with today's presentation. Many of you here are rookie teams, and rookie teams are the ones that are still learning to walk. They are often using kitbots and will not have developed the experience necessary to compete at higher levels yet. And then there's the ultra competitive. The ultra competitive teams are the ones that you know will win worlds. They use complex designs and hit the ground running every season with a powerful robot. Today, we want to show you how to get to the middle step. We want you to be competitive enough to have a working robot, as that's probably one of the biggest joys of FTC, having a working robot and being able to complete on a certain level. Because once you get past that rookie stage and you get to that middle step, it is very easy to become ultra competitive once you start learning more and more about FTC. So let's get right into it with design. All right, Chuckleheads.
Yep. All right, so I'll be presenting on the design portion of this. If we move over to the next slide with design process, I just want to go over how teams should go through designing their robot, and more importantly, just the general systems of parts in their robot. So having a set design process is absolutely crucial for making steady progress on robot construction. So a lot of teams have different design processes, but here's just the general basics of how it'll work. You're going to want to start with brainstorming ideas to solve your problem. For example, this could mean determining whether you want a claw or an active intake. It can also mean determining what drivetrain you'd like to use, the pros and cons between each idea. So once you settle on what you'd like to do, you're going to want to CAD your design in its entirety. You're going to need to make sure you account for every scenario that could happen in gameplay when you're designing. So if we're going after this year's game, you need to design an intake that can handle samples or specimens in later game. So after that, you're going to want to create a functional prototype of your part. So actually make it. Don't attach it to the bot yet. Just test its functionality individually. And if you notice, hey, this part doesn't really work, you can always move back to steps 1 or 2. Finally, once you think your part can actually function, you'll put it on the robot and test it out. So by then, you'll determine whether it'll work as a production design, and you can manufacture it with a better material, or just use the prototype that you've already manufactured if you think it'll be reliable enough. All right, next slide, please. So, designing your robot. Most teams use CAD to fabricate custom parts for their robot. For those who don't know, if you're very new to FTC, CAD is computer-aided design. I'll get into a little bit more on how to do that in the next slide, but for now, just know that it's basically designing. The majority of teams have used 3D printed or CNC machined parts to heighten their robot's ability in the game. So you can always CAD the functional parts and make them yourself using a 3D printer, CNC machine, laser cutter, or even just manual tools. So you can CAD the individual parts, but most advanced teams will create a full digital twin, which isn't just a design of the parts of the parts on the robot, but is a design of the robot itself. So you can put your new parts on the robot and see how it will look before you actually manufacture them. All right, next slide. There are multiple softwares you can use for computer-aided design. The most basic of these is going to be Tinkercad. It should not be used for FTC, but if you're brand new to computer-aided design, it's an interesting place to start. And unlike the other softwares, it's not sketch-based. So in most computer-aided designs, you'll make a 2D sketch and extrude it to make it 3D. It's kind of hard to explain here, but the premise is you'll create a 2D drawing of what you want to do, like a top view or a side view, and then you'll hit a button in your software that will let you extrude it into a third dimension. So FreeCAD is a program that I've found to be relatively similar to AutoCAD. It's still in development, so it's sometimes a little bit buggy, but it's, as the name suggests, it's free and still relatively easy to work with. One more piece of software is SolidWorks. It's the most used design software in the professional world, but it's a very heavy software. It's a very heavy program overall, and it's a bit advanced for FTC, but you can use it to CAD pretty much anything you'd ever need, and it's most used in the professional world, as I mentioned earlier. Next on the list is Fusion. A lot of teams use Fusion. It's a computer-aided design application made by Autodesk for modeling and simulation. It is a bit of a beefy program, but you can do pretty much anything you'd need on it. And for FTC, most teams use Onshape, which is web-based and can run on most devices. It also has a built-in parts library. So instead of needing to import the files for commercial off-the-shelf parts, there's a library built into Onshape that you can download and put directly into your model. All right, next slide. Another part of the design phase that is incredibly important is having a backup plan. So sometimes your parts will break or not even work in the first place, and this is very much why backup plans are necessary. If you know that a part will absolutely work, it's best to have a spare ready to go if something breaks. If you're unsure as to whether it'll work and you need to go back to step 1 of the design process as mentioned earlier, and you can choose a different idea, it is never ever shameful to have or use a plan B. It is the best thing you could possibly do. Please note that backup plans are imperative in the world of robot building and just generally the real world. Next slide. Going back to design, when in doubt, cat it out. It is incredibly helpful to design things in the world of prototyping. Sorry, stuttering a bit. It is very, very helpful to prototype on a CAD software before you actually manufacture it. So that way, if it doesn't look like it'll work, you can make the edits before you actually manufacture it. And on the next slide, it'll list goals and objectives. There are 2 main goals in FTC for your robot. You're going to want to design a robot that is fast. It does not matter how complex it is, rather how well it performs. And reliability. Reliability is the most important thing in the FTC design process. Because if a robot is fast and works incredibly well in one match, but it doesn't work at all the next, then it's not really a good robot. So if your robot works well every single time, that is amazing. All right, and I think we can move on to mechanics presented by Typhoon Stormbots.
Okay, thank you. Okay, so the biggest problem that most rookie teams have when it comes to mechanical is that there's so many different types of drivetrains and intakes and outtakes that it becomes very very difficult to choose which one you want to use. So today I will go over the different types of drivetrains and intakes to help you narrow down which ones you want to choose. So let's start off with drivetrains. Okay, so let's go next slide. Okay, so there's four main different types of drivetrains in FTC. There's the tank drive, which can either have 4 wheels or 6 wheels. So some of the pros: it's simple to build, and it's easy to program. It's very durable and reliable. It has good traction, which gives it good pushing power. And also the 6-wheeled variation can drive over bumps really easily. The cons is that it can only move forwards and backwards, and there's no strafing. It's less maneuverable than other options, and it's it's very predictable and less versatile for scoring in games. However, its complexity is low, which makes it a great starting robot for rookies. Okay. Next drivetrain is the Mecanum drivetrain, Kiwi, or X drivetrain. So the Kiwi and X drivetrain is fully holonomic, which means that it can strafe in any direction. It is also easier to build than most other drivetrains, and it's really light and cheaper than other holonomic drivetrains. However, it has weak pushing power, and it can be less stable if you're only using 3 wheels, and it's hard to control without driver practice. So its complexity is about medium. Okay. The next drivetrain is Mecanum. This This drivetrain is very common in FTC, making it really easy to find resources to program it, as well as it being able to strafe and plus doing diagonals. It has a good balance of maneuverability and scoring flexibility. However, it has low traction, which causes it to slip, which also requires careful programming for accuracy. And it's not as beginner friendly as a tank drive or an omni drive. So its complexity is also around a medium. Okay. The final drivetrain is a swerve drive. So pros, it has the best maneuverability, so it can move in any direction while turning. It has high precision, smooth. It looks smooth and professional looking. It can combine speed, power, and flexibility. However, it's extremely complex to build and program. It can be heavy and expensive, as very high maintenance due to the many moving parts, and it's rare in FTC due to its high difficulty. Okay. I highly recommend that most teams want to simplify their design as much as possible with the tank drive, as it's easy to get into and learn. However, once you mastered the tank drive, it will be very important for you guys to move over into Mecanum drives. The jump isn't too big in complexity, but you get so much more maneuverability that it makes it significantly worth it. Okay. Next, we're going to talk about the intakes. So there's two main types of intakes in FTC. There's a passive intake and an active intake. So a passive intake is like a claw, which are simple and lightweight with few parts. They're easy to build with low maintenance. However, it relies on driver precision to grab game pieces and has and needs more precision with driving and is limited control, so it can sometimes be inconsistent. However, with active intakes, it uses motors and rollers to pull in game pieces. So it's faster, more consistent, and easier for drivers. However, it can be more complex, it's heavier, and it also needs more wiring and also can jam in certain circumstances. So next up, we're going to have coding.
Okay, so coding is probably one of my most favorite parts about FTC. If I may, you may have the best well-built robot out there. However, the code can make or break the robot, as it is one of the final steps into building one of the best robots possible to compete at a middle step and have that working robot. Now, there are a few tips that I'd like to go over to help understand the idea of how to code really well. And to start, we're going to code smarter, not harder. Programming can make or break your robot, and small upgrades in your code can equal big improvements in matches. And today we'll be covering those key steps. So, to begin with, Java over blocks. Many teams love to start out with blocks. Blocks are great to learn the basics, but once your robot gets a little complex, they start to hold you back. I highly suggest teams that want to get out of the rookie stage start learning Java. In Java, you have much more control over your robot and your code is easier to organize, and debugging becomes way less painful. Many people love to use on-bot Java as it's much more easier for code transfers. However, I personally use Android Studios as it gives me more access to libraries and sensors and things. So those are some things to keep in mind when you want to go to the next step in programming. Converting to Java is always a big, major move that can help improve your robot. Next up is copying isn't learning. In today's day and age, AI has become well diverse in our ecosystem and our routines. However, you probably don't want to be doing Control C's and Control V's anymore because online code can be unreliable, outdated, or written for completely different robot setups. Even if it runs, you might struggle to integrate it properly into your own systems. And if you don't fully understand how it works, any bugs will be extremely difficult to fix under pressure. And you must remember that when you try and ask ChatGPT questions like this, it's always building generalized code. It won't always build code for FTC. So Control C and Control V is not usually the best option here. However, you can learn while copying and pasting. Before using outside code, you should read through it carefully and write comments in your own words to explain each part. Test the code in small sections so you see exactly how it behaves. If anything still doesn't make sense, reach out to mentors or the FTC Discord for clarification before relying on it. It's always a good idea to figure out what something does fully before implementing it. It makes the debugging process a lot more easier. And one of the last things I want to talk about for the programming section is autonomous. Most rookie teams don't really focus towards autonomous. However, this is one of the best scoring positions for FTC. During the 30 seconds, any points you score during autonomous gets doubled. So you are able to earn much more points if you learn autonomous. And there are 3 options. Number 1 is time-based. Time-based is when you tell the robot to move forward for. However, I highly suggest everyone stays away from this. It's not a real strategy. Timing-based autos are the easiest to code, but they're the least reliable. Small changes in battery levels or carpet friction equals big errors, and only uses for super basic tests, never in real matches. For example, let's say you are running a 13-volt battery, and you tell the robot to drive for 2 seconds. It might drive, let's say, a meter. However, once that battery starts dropping over consumption over time, because you use this for multiple matches, let's say you have a battery that's, let's say, around 11, 10 volts. If you're running a really low battery, you might only be hitting maybe like 0.75 meters. Now, while 0.25 doesn't seem like a lot, over time, that can build up, making your trajectories miss a lot. So therefore, I highly suggest you don't use time-based because battery draws are always randomized and it's not really something that can be easily predicted. So what is there next to do? Encoders. Encoders are much more reliable than time-based autonomous. Encoders are basically these small sensors inside of your motor that track the position and how many times your motor has rotated. The only problem is with Mecanum wheels, they tend to drift or slip on the carpet because they have the rollers on their wheels, which can cause a little bit of lower accuracies. But for the basic autonomous paths, it's completely perfect. Even for this year, Typhoon Stormbots, we ran 3 specimen autos with encoders. So encoders are reliable. They can totally work. Are they perfect? Not really, but they can get the job done. So if you're a rookie team trying to move over to that middle step, I highly suggest you start learning how to encode encoders. And the best part about encoders, it also works on onbot Java, if you're ever curious. And the last one that I want to talk about are path planners. Path planners are a little bit above the middle step, but I think it's important for people to start learning how these work. Roadrunners and Pedro pathing, they use something called a PID controller, which helps build smoother paths. Instead of going at a constant speed, you are going at a variable speed. It helps make your paths a bit more smoother and a lot more accurate. They're the most consistent for scoring, and you can make complicated routes and stuff. However, it does take a little bit of time to learn. You do require Android Studios to code your robot. However, there are so many tutorials out there for how to get Roadrunner working, how to get Pedro pathing working. There's a whole community, which we will be talking about later in this presentation, on how this all works. But even though it takes a lot of time, there are people to help you. It's totally worth it. If you really want to get to be a competitive player or a little bit above that middle step, path planners is the way to go. Now, again, which one do I recommend? I recommend that you don't ever touch time-based. Time-based is not the one to go for. Encoders and path planners are definitely the way to help you make the best autonomous routines. Encoders, they're easy to code. However, they do tend to be a little bit less accurate, but not as much. Path planners, they're the best. Honestly, totally go for them. If you have the time, you are currently 2 weeks away from most people for summer vacation, start learning path planners before you go into the school year and before kickoff begins. I highly recommend that you do one too. Now, I'm going to pass it back over to Chuckleheads to talk about the awards and a bit of outreach.
Howdy, y'all. So a lot of people think FTC is just a robotics game, but it goes far beyond that. There's a significant non-technical aspect to it. So in previous years, nearly half of the advancement opportunities come from awards. So this year might be a bit different. You're going to need both awards and a competitive robot to advance. So you're going to need to be a really well-balanced team between the two. So I'm going to move over to the next slide and talk about what awards are. So there are 9 awards in FTC, and I'm going to go through each one and what it means and how you can get it. The Control Award. The Control Award is an award granted to teams for using advanced sensors and using their robot in a good way during their matches. So a lot of people call it the Software Award. It's awarded to teams with good software. The next award is the Innovate Award. The Innovate Award is for having novel ideas and a novel design on your robot, which is not the same as the Design Award, which is for having designed a good robot that's efficient, but not necessarily innovative. Then come the non-technical awards. These are the 3 awards in the middle row right here. So the first award is the Reach Award. The Reach Award is awarded to teams who have been able to spread the message of FIRST, spread gracious professionalism. And a lot of times this can be achieved through mentoring teams and overall helping people in an engineering-related way. The middle award is the Connect Award. The Connect Award is awarded to teams for not just connecting to people within their community, but specifically connecting to people in the professional world. So a lot of times this means getting mentors from companies or touring different factories and overall learning about engineering in a professional sense. Then comes the Sustain Award. The Sustain Award comes from not reaching other teams per se, not reaching new people with STEM education, but maintaining the STEM education that already exists. For example, this could mean sustaining your team in the future. So having a proven way to get new members onto your team in the coming seasons. And it could also mean sustaining existing educational opportunities for people. For example, if there's a program run at your school already, you can help keep that program going, and that would be a way for you to get the Sustain Award. And then this bottom row of awards right here is the miscellaneous awards. The Think Award. The Think Award is for your documentation and design process. So if your engineering portfolio, which I'll get into what that is in a minute, if your engineering portfolio is well designed and well documented, and overall your design process is proven and shows the judges that you have improved throughout this season, then that's grounds for the Think Award. And then the middle right here, this is the most important award in FTC. It is weighted far above any other award and honestly can get you a very, very good shot at advancing. This is basically the award of all awards. If you are qualified in every award category, then you can get put into the nomination for the Inspire Award. So you're going to need 1 award from the top row, 1 award from the middle row, and the Think Award. You need to be contenders, heavy contenders in one from each row in order to be considered for the Inspire Award. It's given, I believe this year it's weighted for 60 ranking points, which I believe puts you on the level of winning Alliance Captain. So it is incredibly important in FTC if you get this award. And then the final award is the Judge's Choice Award. This is for if you do a really, really good job as a team, but don't necessarily fit into any of these categories. So it's meant for teams that do really, really good work, but the work that they've done doesn't necessarily fall into one of the categories of awards. All right, next is going to be outreach and portfolio. So this is how you're going to get these awards. So here's a look at the non-technical process. There's a very, very, very significant process that goes into all of this. You're going to start by doing outreach. You're going to need to connect with others, whether in your local community or around the world. It's encouraged to help spread the idea of gracious professionalism as well as general STEM education. Next, you're going to compile all of this into a notebook. Now, the notebook won't be submitted or anything, and it's not required for teams, but it's very much recommended for documentation purposes. And a lot of times, if you have a notebook, it will very much help you in the category of the Think Award. And finally, you're going to compile a portfolio. This is a 15-page portfolio containing details about both your robot and your outreach. And you're going to want to focus on each award when making this and keeping it concise. So the judges are going to look at this, and it basically needs to tell them, hey, we are contenders in every award category. We can make this award. So on the next slide, it's going to show a few different ways teams do some outreach. One way is teams often host large events or give talks in order to get a larger crowd interested in STEM education. And, oh, by the way, these aren't the right way to go about outreach. There's no right or wrong way to go about outreach. Every team does it differently. So another way teams will go about outreach is they'll communicate with companies in order to obtain tours and professional mentors. So this piece is really good for the Connect Award in particular. Another way, teams mentor and found other FIRST teams, not just FIRST Tech Challenge, but any FIRST team in general, FIRST LEGO League, for example. That's a big one. So this helps significantly for the Reach Award and will provide a safe bet for assistance to your team in the future. And finally, teams can attend community-organized events and bring their robot, occasionally allowing people to drive it if your team feels comfortable. For example, some of our local elementary schools host community nights in which we'll show up to and bring the robot and let some elementary schoolers drive around the robot. And finally, this is the biggest one, the most important thing you can possibly do in FTC, asking for help. It is a necessity in FTC. No team can go alone and succeed. Fortunately, there are enough resources in the community to turn to if you get stuck. And I know this is going to sound so corny because people are like, you don't need to be afraid to ask for help, but seriously, in FIRST Tech Challenge, you need to ask for help. If you even get a little bit stuck, there are people everywhere ready to jump in and help you at a moment's notice. So here's some resources as to where you can get assistance. My personal favorite is the FTC Discord. It has so many people on it, specializing in so many different things. I believe there are over 27,000 members on it right now, and so many people are on there willing to help you out. Next is Game Manual Zero. gm0.org is the website. It is the ultimate guide to the basic concepts used in FTC. If you have questions of any sort, the answer is likely on there. It has tutorials about pretty much anything you would ever need. Another place you can ask for help is through professional mentors. You can connect with them through outreach, and they will always, in many cases, be able to help you with engineering-related concepts. So if it's not specific to FTC, they can very likely help you. Then there's Chief Delphi. It is a social media platform made specifically for First and Vex Robotics. It is very active and people would likely be of assistance. It's basically a robotics social media platform. And finally, but certainly not least, is Control Alt FTC. It's a website similar to Game Manual Zero and contains a ton of concepts and tutorials to keep you going in FTC. All right, that's pretty much it. Good luck out there, y'all. And if you have any questions, please type them in the YouTube chat. Or you can always find us on the FTC Discord as well. So, yeah, good luck. Now the floor's open for questions if y'all have any.
We'll just be hanging out around here for like another few more minutes. If you guys have any questions, feel free to type them out. And then we will be able to answer them to the best of our abilities. By the way, in case anyone is curious, the VOD will be up for this live stream later today when I get the chance to. Yeah, so if you want to I'll also have the slideshow link in the description below. So if anyone wants to check it later out, you totally can. One. All right, I don't see any questions popping in the chat, so I think, yeah, if you guys have any questions, feel free to DM me on Instagram to the Typhoon Stormbots account, or in case you're curious, Chuckleheads and I are very active on the FTC Discord, so you'll probably see us there in and out. If you have any questions, you can always ask there. Yeah, thank you everyone for coming out, checking out our live stream. I hope a few people learned and are able to take their decode season to a whole new level thanks to the amount of things they learned from this. And hopefully you are all able to design really good robots that are very competitive If you're in the Texas or Ontario regions, we can't wait to see you in our tournament. Good luck, everybody, in Decode. Have a wonderful day, night, wherever you are. Yeah.
Good luck in
Alright.
Decode, y'all. I look forward to seeing you on the field.
Good luck.
Bye.